In this video, we're going to continue. We're going to continue with this, with where we left off in the last video. Is to create an instance. Is to create an instance of my type class monad trans here. So what I'm going to do now is I'm just going to complete where we left off. So using this type class, I'm going to now create an instance. I'm basically going to create an instance of this, and the way I'm going to do this is let's actually uh, say it in this fashion here. So I'm going to say class. That's my type class definition here. I'm going to say this as instance and of my monad trans. Okay, and t in this case is going to get replaced with maybe of t. Okay, and let's do this. So this now again might be a little bit not I might make a certain typos over here with my Haskell syntax. But again, actually I'm trying to give you a theoretical understanding, and so if I forget where and things like that, just please try to ignore that. And I'm going to make maybe and sometime in the future a next set of videos where I'm going to put all of this a lot of this theoretical material actually in some Haskell code by typing the code out and showing you everything a little bit in practice. So I've got my instance monad trans maybe t where now this is the behavior. This is the behavior that needs to get implemented in my instance. So the behavior is a lift monad. So it's basically a method lift that takes in as an input ma and gives back as an output a TMA. And the class constraint here is that M is something that must be a monad. So I'm just going to take this, I'm just going to write this a little bit clearly. So I'm just going to take that signature. I'm just going to write a little bit clearly over here where I'm going to replace everywhere, wherever I see a T, I'm just going to replace that with a maybe of T. Okay, so my signature over here is basically, I'm looking at my lift method where the class constraint is that M must be a monad, and that's my class constraint, and the method takes in as an input some value of type MA, and out comes back another value of some type TMA, where T in this case is maybe of T, so this is basically maybe of T, and M MA. All right, so this is basically what I really have to implement. This is the behavior that must be implemented in my instance of monad of trans. Okay, so let's do that. Let's implement this. So I'm going to say left. What does left do? Well, it takes in a value. It takes in a value of some type MA, right? So I'm just going to say left of x, okay, where the type of x is basically MA. Okay, and what does it give you back as a return? It gives you back as a return some value that has a type. It has a type of maybe TMA. All right, so that's the type of maybe T of MA. What is one such value? What is one such value that may have a type of maybe T of MA? Well, one such value that has a type of maybe of TMA is this value right here. That's a type constructor. Maybe T is a type constructor that I can use to create that value. So one such example for this could be something of the kind, something as an example, some value of type maybe TMA could be, I'm going to invoke my value constructor maybe T, and inside it I might pass in something of this type, the M maybe of A. Okay, so if I have some value of that thing, okay, this piece over here, and maybe let's just for the sake of example, if I call that value as Y, and then I can just say, in this case, I can just say uh, uh, okay, I can just say Y there, and this entirely is going to construct for me some kind of a value that has a type of maybe T of MA. Okay, but I'm going to assume that the type for this value Y is of the type M of maybe of A. Okay, so that's kind of the understanding, just to give you some kind of intuition as to how we go about complete this method, lift x here. So first thing what I'm going to do now is in this in this value in this value x over here, which has a type of ma. I would somehow like to tear it apart, somehow like to tear it apart, where I can get these two pieces out. I can get these two pieces out, which is basically one is the side effect that could be represented by my monad m here, and the actual value which is represented by this type variable a. Okay, so how would I do that? Well, because this value x over here is actually a monadic value, I can in some sense actually use the do block. I can use the do block, or I can actually use the bind operator. I can use the bind operator to tear apart the value represented by the type variable a from that monadic value of ma. So I can say at this point, let's not use a do block just at this time. Let's actually use the bind operator. So I'm going to say, all right, let's take this x, whatever this x is. Let's call the bind operator on x. Okay, so that's my bind operator. This entire thing over here is my bind operator. And the bind operator takes in as a parameter, the second parameter of my bind operator. So signature for the bind operator. If I were to write a signature for the bind operator, the signature for the bind operator is basically it takes in a monadic value ma, and then it takes in a function that goes from a to mb, and in turn it gives back a value of type mb. So this ma is right there, is this x, is that x there, and now it needs a second parameter, which is this function that goes from a to mb. So let's have this function that goes that takes in as a value the actual computed value in this monadic expression, just the a part here. Okay, whatever that value a here, which so this method should return back something of type mb, and in this case whatever m that I'm dealing with right now is this m here, is this monad m right there. This could be an IO monad, it could be a list monad, it could be any monad, but that's the monad m I'm currently dealing with. So what this is going to do is this is just some method. In this case, I take in this a, and what does this function should return back to you? Well, this function should return back to you. It should basically return back to you something that's of type. Okay, so where's this? Oh, there you go. That's my method right there, and it should give you something of type mb. All right, so mb. All right, so I'm just going to, in this case, I'm going to keep things a little bit simple, but I'm just going to say, okay, let's take that pure value which I just got here, a. Okay, and I'm just going to call return on a. Okay, and if I call return on a. Okay, so what's going to happen here is lift takes in some value. It takes in some value. This value has a type. It has a type which is ma, right? And out comes back another value which is of type maybe t of maybe t ma. All right, so how do I create a value of maybe t of ma? In order to create a value of type maybe tma, I need to invoke my type constructor maybe of t. So I'm going to invoke my type constructor, maybe t, and this type constructor needs to take in as a value. It needs to take in as a value of some type, which is m maybe of a. Okay, m of maybe of a. Now how do I create a value? How do I create this value which has this type m maybe of a? All right, so how do I pass in that value in these ellipses here? That's going to be something of that type m maybe of a. Okay, so the way I'm going to do that is that if I already know. Okay, so let's think about this. If I somehow from this x, if from this x, which is the monadic value of type ma, if somehow I can tear it apart, if I can tear it apart so that I can get this A out from this monadic expression, I can then take that A, and just just create some kind of a value that happens to have a type of maybe A. I can simply do that by just of A, right? Just of A is just going to be some value that has a type of maybe of a, and then I can take this value, I can take whatever this value is, and just wrap it up in the return expression, so that this entire thing over here is going to be a monadic value, which is going to be m of maybe of a, and on that I can run my type constructor maybe of t to get back the eventual answer I'm looking for. So what I'm going to do now is I'm just going to erase this piece over here slightly so that we can complete this off. And so maybe of t, maybe t there, and inside this first I'm going to figure out how am I going to tear this x apart. Well, to tear that x apart, I can simply use my either the do block, because I know x is some kind of a monadic expression and the do block is basically applicable, or I can simply use the bind operator. Okay, so I'm just going to go with the bind operator just to show you a little bit of the things that are happening in the background. So I'm going to take this x, this monadic expression x. I'm going to call the bind operator. I'm going to call the bind operator so that it actually separates the x out from the monad, and this is going to result back in some kind of a function. The second parameter that goes into the bind operator is the function that takes in this pure value a. Okay, I got that value that I'm looking for. Okay, this is that value that I was looking for, the actual value devoid of any of that monad. Okay, so that's this value of belonging to the type variable a, and at this point this function that I'm just going to pass in as a second parameter to the bind operator is going to is going to return back is going to basically return back some kind of a value that happens to be of type m of maybe of a. Okay, so how do I make this function? How do I make this function that I'm just writing here? This function that I'm writing, let me just put it just in brackets just to make it a little bit clear. This function that I'm just writing right there, right? These dots over here. How do I complete these dots so that it returns back some kind of a value that has a type of m of maybe of a. Okay, how do I do that? So at this point I can simply say this entire thing, I can take this a that I've just got there, this a, wrap it up inside, create some value that happens to have a type of maybe of a, which is simply using just of a. Okay, so this piece is done. This piece over here is done. And now, how do I wrap it up in this monadic expression? I can do that by just calling return on this entire thing, return on this entire thing. Okay, this after after calling return on this entire thing, this function, which is in this brown color, is going to have a type of m of maybe of a, and I'm going to take the type m of maybe of a, okay, which is going to be the type for this entire entire expression, which is which is this piece over here, this entire thing, this entire function in this slightly, I guess, a slight yellow color is going to have a type of m of maybe of a, and on that I'm going to run the value constructor. I'm going to run the value constructor maybe of t, and running a value constructor maybe of t is now going to result in basically a value which is going to have a type of maybe t of ma. Okay, and again, I can definitely get this a little bit more simplified. I can get this a little bit more simplified by just saying lift of x equal to is equal to maybe of t, and this is nothing but it takes in x, and instead of creating this anonymous function, I can just use function composition where I can say return dot just. Okay, and this should be okay. It should basically be this piece over here and this piece over here are completely equivalent to each other.